Let's continue with this paper. Now we are on question number 9. Question number 9 is about differential equation. Let us first separate the variable. So 1 over y dy, that is equals to 1 over x plus 1, 3x plus 1 multiplied by dx. Double check. These are actually the x terms and this is dx. So x term and dx. Similarly, this is dy and this is y. This is 1 over y and this is dy. Now when we look closely, is the right hand side in a position, in a scenario that it can be integrated? The answer is no, it's not in such a position. That means what needs to be done? Something called partial fraction needs to be done. So first of all, let's focus on partial fractions. Partial fraction, first of all, it's a proper fraction. That's the first thing. So long division is not needed. Second thing, this is case 1 of partial fraction, that is denominator with linear factors. So this is something that you need to decide. Believe me, P3 paper, or for that matter any math paper, it's about logical thinking. It's not just about crunching some numbers in the calculator, it's about logical thinking. So basically, follow and write down every step that needs to be done. So this is the main thing that you have to do. So therefore 1 over x plus 1, 3x plus 1 is identical to a constant over the first factor, another constant over the other factor. That is the first step. Second step, take LCM. A is multiplied with 3x plus 1, b is multiplied with x plus 1. Make sure to use a lot of brackets. Now let me choose a constant. Let x equals to negative 1. So b disappears. 1 is equals to negative 2a. Therefore, a comes out to be negative half. Similarly, let x equals to negative 1/3. This time a disappears. And 1 is equals to, this comes out to be positive 2/3 b. Therefore, b comes out to be 3 over 2. That's the first thing. Second thing, let me simplify the fractions as much as possible so that it's in a position to be integrated. Let me first simplify as much as possible. So now basically I'm looking for a rectangular shape and it suddenly became a parabola. I don't know what's the issue. Let me try it one more time. So now it's completing a rectangle like this and that sounds perfect. So let me just take it down like this. Now what you will do is that you have a as the numerator of x plus 1. So this is negative half. This is 1 over x plus 1 and this is positive 3 over 2, 1 over 3x plus 1. That's the first step. Now let me shuffle it around. Let me take half common out. This is 3 over 3x plus 1 and this is 1 over x plus 1. That is the second thing that I have done. Now it's in a position so that it can be integrated. What else do I need to tell you? That is integral of 1 over ax plus b dx. That is 1 over a ln ax plus b plus a constant of integration c. Similarly, if the numerator is the derivative of denominator, listen to me once again. If the numerator is the derivative of denominator, then the integral is ln of denominator plus a constant of integration c. Now coming back to this. First of all, write down the partial fractions, all that we have done at the corner. So this is 1 over y dy. This is half common. and this is 3 over bracket 3 over 3x plus 1 minus 1 over x plus 1, something like this. Put a dx over there, put the sign for integration, put the sign for integration. Now it's all ready. Let me call this thing as rule number 1. This is again the same rule but written in a different style. This is rule number 2. So therefore, if I apply some colors, so this is rule number 1, and rule number 1 is applicable over here, rule number 1 is applicable over here. So therefore, rule number 2 is this thing. So this is rule number 2, something like this. So now when we start with the integration, what happens is that we have a 1 over 1 ln of y, half as it is, and the numerator 3 is the derivative of denominator. Therefore this is ln of 3x plus 1. This is minus as it is, 1 over 1 ln of x plus 1, bracket closed, plus a constant of integration c. Now think closely, watch closely, observe that these are the main things that we have done so far. Now what we do is that let me plug in these conditions. So this condition is y is 1 when x is 1, y is 1 when x is 1. So therefore when I plug it in, this is 1 over 1 ln of 1, this is half, this is ln of 4 minus ln of 2 bracket closed plus c. Ln of 1 is 0 and this minus rule of log is applicable. So that is half. This is ln 4 divided by 2 plus c. This is half ln 2 plus c equals to 0 equals to 0. Therefore c comes out to be minus half ln 2. So another half is there. Now this particular step, which is this purple one, write it all over again. I'm writing it over here. So therefore this is 1 over 1 ln y, that is equals to half, and now this is ln 3x plus 1 and then minus ln x plus 1, and this time I can even take this thing common out, and this minus, this goes on the inside. So therefore this is minus ln of 2 and the bracket is closed. Half is already taken common out. Now do I need to solve the differential equation? Actually I've already solved it. Differential equation is solved. I don't need a particular format. I need the exact value of y when x is equals to 3. Now x is equals to 3, find exact value of y. So therefore ln of y is equals to half, plug in 3, 3 3s are 9, 9 plus 1 is 10, minus 3 plus 1 is 4, minus ln of 2, this is half as it is. There are two negative signs, so 10 is at the top, 4 and 2 is at the bottom, bracket closed. So this is half ln 10 over 8, which comes out to be 5 over 2, 5 over 4. So that is the value for this one. This is equals to ln of y. Therefore, ln of y, one more step, that is ln 5 over 4 raised to power of half. Now the rule is, when you have log m base a equals to log n base a, in other words m is equals to n. So this is ln, this is ln, and then therefore we have y is equals to 5 over 4. Let me write it properly. This is 5 over 4 raised to power of half. That is the exact value of y, because calculator is not used. So that was a 9-mark question, but required a lot of effort. The next question. Now this time the question is about vectors, and let's continue with this. The points A have position vectors 2, 1, 1. The point B have position vector 1, minus 2 and 2. And let me calculate AB because I have a feeling I will be needing this. That's OB minus OA. So therefore 1 minus 2 is negative 1, minus 2 minus 1 is negative 3, 2 minus 1 is 1. And if I flip all the signs, I'll get BA, that is positive 1, positive 3, negative 1. So now first of all, it says find a vector equation of the line through A and B. So there are two options for the fixed point. There are two options for the direction vector. So therefore this is the option for the fixed point. And the purple one is the thing for the direction vector. So therefore now let me proceed. So therefore R is equals to something plus lambda something. The easier number looks like 2, 1, 1, and the easier direction vector looks like 1, 3 and minus 1 because of lesser negative sign. So this is line AB. That's the equation for this one for 3 marks. Find the acute angle between the direction of AB. What is the direction vector of AB? That is this 1, 3 minus 1. So direction vector of AB is 1, 3 minus 1. And what else is there? We also have the direction vector of line L, which is 1 minus 3 minus 2. Direction vector of line L is 1 minus 3 minus 2. Let me double check. 1 minus 3 minus 2. Perfect. So therefore acute angle between the direction vectors. So 1, 3 minus 1. Dot product with 1 minus 3 minus 2. Square root cosine of theta. For the first one, this comes out to be square root 11. For the second one, double check, this comes out to be square root 14. And then you would multiply it selectively. You multiply the I with the I, you multiply the J with the J, you multiply the K with the K. So I into I, J into J, K into K, that's 1 into 1. That's 3 into minus 3. That's minus 1 into minus 2 divided by root 11, root 14, that is equals to cosine of theta. Now the numerator after simplification, it's coming out to be minus 9 plus 2 plus 1, that is minus 6, this is negative. That means theta will come out to be obtuse. Now the easier version, remove negative sign from numerator and your theta will come out to be acute. That's the easy way. So therefore cosine of theta equals to 6 over root 11 root 14. Hence you will find the value of theta correct to 1 decimal place. So that's the working for this particular part. Now what does it say? It says show that the line through A and B does not intersect the line L. It means skew lines. So therefore the working for skew and intersection is the same. Let me write the equation of line through A and B. So line AB, this is R is equals to something plus lambda something. Line L, this is R is equals to something plus mu something. First let me write L 1 2 minus 3 1 3 minus 2. 1 2 minus 3 1 3 minus 2. Line AB, this is 2 1 1 1 3 minus 1. 2 1 1 1 3 minus 1. Now let me do some highlighting. First of all, this equation and this equation would be the same after I open it up. So let me first open it up. So therefore this is 2 plus lambda, 1 plus 3 lambda, 1 minus lambda, that's the first one. This is 1 plus mu, 2 plus 3 mu, minus 3 minus 2 mu, that is the second one. Now let me underline this thing. So this equation and this pair of equation and the last pair of equation. So you have 3 pairs. Choose any two. 2 plus lambda equals to 1 plus mu. That is equation 1. 1 plus 3 lambda equals to 2 plus 3 mu. That is equation 2. Now solve simultaneously. That's the first part. So therefore, lambda equals to mu minus 1. That's the first equation. Plug it in. 1 plus 3 times mu minus 1 is 2 plus 3 mu. 1 plus 3 mu minus 3. And if I'm not mistaken, this is mu minus 1. That's correct. Minus 3 is equals to 2 plus 3 mu. Why is the mu cancelling out in this one? Must be some mistake. So let me double check. Line AB is 2, 1, 1, 1, 3, minus 1. This is 2, 1, 1, 1, 3, minus 1. That's perfect. Line L is 1, 2, minus 3 and 1, 3, minus 2. 1, 2, minus 3, 1, minus 3, minus 2. 1, minus 3, minus 2. That's the mistake. So therefore, let me just correct it. 1, minus 3, minus 2. And this one is, let me use an eraser over here, eraser over here, eraser over here. So therefore, 2 minus 3 mu, 2 minus 3 mu, 2 minus 3 mu. So therefore, 3 mu plus 3 mu, that is 6 mu. And 2 plus 1 is 2 plus 3 is 5. 5 minus 1 is 4. Therefore, mu is 4 over 6 or 2/3. Therefore, lambda is 2/3 minus 1, which is minus 1/3. Now plug in equation 3. So therefore, 1 minus lambda, is it really equal to minus common 3 plus 2 mu? Let me double check. 1 minus minus 1/3, which comes out to be 4/3. Is it equal to minus common 3 plus 2 times 2/3? So therefore, this is minus 3, 3 cancel. Sorry, it won't cancel. This is 3 plus 4/3. No, it's not equal. Therefore, since lambda and mu does not satisfy all three equations, therefore the lines are skew lines. So this question is also done. Now question number 11 is the last question, and this question is about, the first part is about differentiation and the second part is about integration. So this is integration, excuse me, and this is differentiation. Now it says the diagram shows the curve y is equals to such and such. So y is equals to sine x cosine 2x. X lies between 0 and pi by 2 and its maximum point in. Find the x coordinate. Give your answer correct to 3 significant figures. U is equals to sine x. U prime equals to cosine x. Du, I sometimes get carried away and go and enter the boundary of integration by parts. This is product rule. V is equals to cosine 2x. V prime is negative 2 sine 2x. So therefore, this will multiply with this will multiply with this. So therefore, dy by dx, that is sine x into minus sine x multiplied with minus 2 sine 2x. And again a plus sign, cosine x multiplies with cosine of 2x. Now let me first open this up. This is sine x. This is minus 2. This is 2 sine x cosine x. And this is cosine x. And you have cosine 2x. I am unsure which option to use. Let me further simplify this. Or if I take common as 1 minus 2 sine square x, or 2 cos square x minus 1, I think I'll go with 1 minus 2 sine square x. Let me proceed and let's see what happens. Can I take something common out? I can take this cosine common out and this cosine common out, and I think other things would simplify. So let's proceed with this and let's see how it goes. So now let me take cosine x common out, and this is 2 into 2 is 4, and this is negative 4 sine square x. And over here, this is 1 minus 2 sine square x. I think that goes pretty well. So now when I open up the brackets, what happens is that you will get this value. this is cosine x, and this is 1 minus 6 sine square x. Now when you have this thing, so therefore dy by dx equals to 0. In other words, cosine x 1 minus 6 sine square x equals to 0. In other words, cosine x is 0. When is x 0? X is equals to pi by 2. Reject this value because this is not what I am looking for, and it doesn't look like this because pi by 2 is at the corner. Therefore 1 minus 6 sine square x is equals to 0. Sine square x is 1 over 6. Sine x is equals to plus minus 1 over root 6. But since we are looking for x between 0 and pi by 2, so we are only looking at the first quadrant. Let me double check. 0 to pi by 2. So basically sine x is 1 over root 2, 1 over root 6, and hence you will find the value of x, and that answer comes out to be 0.421 radians. So that is the working for 6 marks, and the last 5 marks, that is about integration. Find the area of the shaded region enclosed by the curve in the x-axis in the first quadrant. So you have this equation, y is equals to sine x cosine 2x. Y is equals to sine x cosine of 2x, and now you have first of all y equals to 0, therefore sine x cosine 2x equals to 0. Sine x equals to 0, therefore x is 0, or x is pi by 2, or x is not pi by 2, x is 0 and x is pi, and so on, but reject this thing. And then it says cosine of 2x equals to 0. Therefore, when is cosine 0? 2x is equals to pi by 2, x comes out to be pi by 4. This answer makes perfect sense. So now the second thing, your function is sine x cosine 2x dx between the limits 0 to pi by 2, and you are looking for the area of this shaded region. Is that so? Yes, that's the one. What else is there? Now you are looking for a substitution. U is equals to cosine x. Let me start with this. Therefore du is equals to minus sine x dx. In other words, negative du is equals to sine x dx. So therefore this is sine x, this is dx, that will be shifted to negative du, that will be substituted. That's the first thing. So first of all, write this thing as 0 pi by 2, this is a negative sign, this is du, and what should I do with cosine 2x? I can write this thing as 2 cos square x minus 1. U is cosine x, therefore u square is cos square x. So therefore this is negative 0 to pi by 2. This is 2u square minus 1 du. So far so good. This is what you have reached. Now what should we do? Either we can flip the limits with the negative sign, or we can first change the limits. So let me change limits. So therefore u is equals to cosine x. When x is 0, u is cosine of 0, which comes out to be 1. And when x is pi by 2, u is cosine of pi by 2, which comes out to be 0. So now let me write it. There is still this negative sign on the outside, and the lower limit 0 gave us 1. So 0 gave us 1 and pi by 2 gave us 0. So now it's time for the flipping. So this is 2u square minus 1 du, and this becomes a plus sign. 1 goes up, 0 goes down. This is 2u square minus 1. Yes, that is what P3 is all about. You can't cry and whine at this moment, because this is what P3 is all about. You have to work your way all the way to the top. So this is 2u cube over 3 minus u between the limits 0 and 1. When you plug in 1, this is 2/3 minus 1, and this is 0 minus 0. Now let me just double check one thing, that is this integration becomes 2u cube over 3 minus u, and your limits, let me double check the limits. Okay, one small mistake, that is, this is not pi by 2, this is pi by 4. This is pi by 4, this is pi by 4. So the limits would be changed like this, and let me erase this step. So this is pi by 4. So a red marker over here, cos of pi by 4, this is 1 over root 2. Because how did I got the feel that I got it wrong? Because the answer was coming out to be negative, even the area was above the x-axis. That's how I captured my mistake. So therefore, this is pi by 4. And this 0 is giving me 1. And this is giving me 1 over root 2. So 1 over root 2 goes down and 1 goes up. So now this is 1 over root 2 goes down and 1 goes up. So this is 1 over root 2. So therefore, 1 over root 2 cube, that will become 1 over root 2 square into 1 over root 2. That comes out to be 1 over 2 root 2. Let me write it like this. So when I plug in 1, this is 2/3 and this is 1 minus 1 and this is minus 2/3. After the cubing, this comes out to be 1 over 2 root 2 and u is 1 over root 2. So therefore, this 2 and this 2 cancels off and this is 2/3, this is minus 1, this is minus 1 over 3 root 2 and this is plus 1 over root 2. So therefore, this comes out to be 2/3 minus 1 is minus 1/3 and then which is minus 1 over 3 root 2 and this plus 1 over root 2. I think this is a good enough answer because they are giving the answer in a simplified exact form. I can even take 1 over root 2 common out, but I think this is more than enough. So this is the exact form and that completes February 2022 P3 paper. Take care.